For multiple representations of linear relationships, our objective is going to be to identify linear relationships in multiple representations, which includes your tables, your graphs, your equations, and also in a verbal description, which is your word form. Now, remember, for linear relationships, we are still using y equals mx plus b, where m is the number that you're multiplying by. We call that our rate of change. We also call that our coefficient. It can be called the slope. And then you also have your keywords of per, each, and every. Of course, there are others, but these are 3 of the main keywords we use when identifying our rate of change. Now, the second part that we add on is the number that you're adding. For that, we use the variable of a b. Here, this is called the y-intercept, but it can also be called your constant, your initial starting amount, and then you have some keywords of one-time fee, registration fee, flat fee, admission fee, basically that one-time amount. Okay, so here you have a four-corner model. In this example, it is using the equation of y equals 2x plus 1. So the 2 is your rate of change, your m, the number you're multiplying by. The positive 1 is your y-intercept, your b. And if you look at the word form, it's stating the total cost of a chocolate bar for $1. Notice it is singular. It's saying a chocolate bar, hence our y-intercept. And slices of pizza for $2 each. Keyword here, each, lets us know we're multiplying. Now, whenever you identify what your initial amount is, which is that $1, that is what y is going to equal when x is 0. So you already have one ordered pair, which is when x is 0, y is 1. So we can check the rest of our equation, our table, using our equation. For example, here, if it says that they're going to buy 2 slices of pizza, you could replace x with 2. Therefore, instead of 2 times x, it's going to be 2 times 2 plus 1. 2 times 2 gives me 4, and 4 plus 1 gives me 5. Now I can check the next one, replacing x with 3 this time. What if you want to buy 3 slices of pizza? Well, 2 times 3 is 6, plus 1 is going to give you 7. From here, now that you have your ordered pairs, you can go ahead and plot them on your grid to check your line. When x is -2, y is -3. Remember, you walk before you jump, so I'm going to go to the left horizontally. And because since x is negative, I'm going to the left 2. And then since y is negative, I'm going down 3. And that point does fall on my line. For our third ordered pair, when x is 2, so I go over 2, y is 5. I plot my point. And our last ordered pair, when x is 3, y is 7. And I plot my point. Notice how your points form a straight line, hence the word linear relationship. Okay, let's go ahead and practice one. Here we have y equals 3x plus 2. Remember, the number you multiply by, that is your m, your rate of change. And here, the 2 is your b, which is your initial amount. Okay, so let's say for this one, that you're going to the store and you're buying, you purchase a soda for $2. Keyword here, a. That's singular, letting you know it's that one-time amount. And you also purchase bags of chips for $3 each. Keyword here, each, letting us know we're multiplying. Okay, so let's set up our table. Say you decide to buy 0 bags of chips. Well, you're still going to spend $2 on that soda, giving us our y-intercept, our initial amount. When x is 0, y is 2. Now, let's say you want to buy 1 bag of chips, hence your rate of change of 3. For 1 bag of chips, you're adding $3 to your total, now making it $5. And remember again, you can check your work by replacing x with what we said x equals 2 of 1, adding 2, and see if it gives you 5 for y. 3 times 1 is 3, plus 2 more does give us 5. Okay, let's say you want to buy another bag of chips. 1 more bag of chips means you're spending $3 more. Now your total is going to be $8. So I can make my points when x is 1, y is 5, when x is 2, y is 8, and let's do another one. When x is 3, you're adding 1 more bag of chips, so that'll be $3 more to your total. Now we're at 11. And again, whenever you have a linear relationship, it's your points once you graph them. Whoops, that came out a little bit too big. Are going to form a straight line. Okay, so for number 1, let's try this one together. Notice you're not given all 4 representations. You're given the word problem, and it wants you to identify the table. So I'm going to look at my equation, and I'm going to look at the number that I'm multiplying by. It's 4 cents. I'm also going to look at the number I'm adding on, my initial amount of 45. Because remember, when x is 0, y will be 45, since this is our initial amount we're working with. Now, none of our tables have x equaling to 0. So another option we have is similar to what we just did in our example, using our equation of c equals 45 plus 4 cents times m, and just replacing m with the value given in your table. So I'm going to try times 3 and see if it gives me the total for C. So here I'm going to multiply first. 4 cents times 3 gives me 12 cents. $45 plus 12 cents does give me $45.12. So we can check the next one. Again, using the same equation, except this time we're going to replace m with 10. So from here, we're first multiplying 4 cents times 10, giving me 40 cents, and thus this does give me $45.40. So we can check the third one. This time replacing M with 17 cents. So from here, we're going to first multiply the 4 times the 17, giving us 68 cents. So when M is 17, C should be 45.68. Notice that's not what you have here. You have 45.86. So can A be our answer? No, that one is out. Now looking at our second table, we already calculated that when M is 10, C is 45.4. So that one is correct. But notice on that second table, it does the same value you see here on A of 45.86. But we already said that this should be 45.68. Therefore, B is out. So from here, we can move on to C. Same thing again. Replacing M, the number of miles, with 4 this time. And then 4 cents times 4 gives us 16. So when M is 4, C should be 45.16, and that is correct. Now we can try 11. Same equation again. You're replacing M with 11 this time. 11 times 4 cents gives me 44. That does equal out. Now we can check 16. 16 miles at 4 cents a mile. So here now we would multiply 16 times 4 cents. That's going to give you 64 cents. So for 16 miles, it should come out to 45.64, and that one is correct. But we still have to check the last one. Using our same formula of 45 plus 4 cents times, and in this case, times 25. So here we have 4 cents times 25, and that's going to give us $1 whole. Now for a total of 46. Okay, so this is one option, just checking your table, checking your X and Y values to see which one is correct. The other option you do have of just checking your change in Y, dividing by your change in X to see if it matches up with the 4 cents every time. For number 2, if you want to pause the video and go ahead and try it on your own, or if you just want to continue with me, that's fine. For number 2, it says at the beginning of 2019, Milos owned 30 model cars. If he purchases and builds 2 models each month, which of the following table represents the number of cars he has in M months after January 1st, 2019? So notice how it says beginning of 2019. So what was Milo starting out with? Well, he was starting out with 30 cars. Therefore, when X is 0, Y is 30. From here, it tells you each month, he's going to purchase and build 2 more. So after 1 month, he's adding 2 more. So now he has 32 cars. Another month passes. He's adding 2 more. Now he has 34 cars. So this is another option you have of just building your table from the equation and seeing which one matches with your table. After another month, he adds 2 more cars, making it 36. From here, I can already see that A is out and C is out, because at 3 months, he should have 36 cars. Now let's continue. 4 months, 2 more cars, now giving me 38. And we add another month. Now we're at 5, giving us a total of 40. From here, now I can just eliminate B, because when X is 5, Y should be 40, giving me my answer choice of D. Okay, 3. So same thing again. If you want to pause the video and try out the question on your own, or if you just want to do it guided with me, it is up to you. For this question, it's asking which of the following statements best describes the relationship between X and Y shown in the table. Now, we do not know what our initial amount is, but we can also identify what our rate of change is. Remember, by doing your change in Y divided by your change in X. And it doesn't matter what 2 ordered pairs you choose.
Mommy.
So if I can choose the first 2, X is 2, Y is 5, or because that's an improper fraction, I'm going to jump to an X is 4, Y is 6. My change in Y is 1. My change in X is 2. This giving me my rate of change of 1/2. Now let's look at our answer choices. Answer choice A is saying the value of Y is 3 more than X. Well, for A, it is true for the first ordered pair. But then when you look at the second ordered pair, if I add 3 plus 3, am I going to get 11 over 2? No, I'm not. I'm going to get 6. So we can move on to B. The value of Y is 1 more than 1/2 of X. Now, notice how we talked about the rate of change being 1/2. And I can already see in answer choice B that it's giving me my 1/2. And you can also see that D is. Now, that 1 more, keep in mind, is coming from the initial amount, which we don't know right now. So I can try this out. For example, here, taking 1/2 of X, which is 1, adding 1 more to it. So it's saying 1/2 of X plus 1 gives me Y. Well, 1/2 of X and our first ordered pair is 1. And does 1 plus 1 give me 5? No, it doesn't. So we can eliminate B. Now C is talking about the value of Y is less than 3 times x. Okay, we can try that one out as well. The value of y is, remember that means equals, 1 less, so I'm going to subtract 1, 3 times x. Same thing again, we can try our first ordered pair. Replace y with 5, replace x with 2. 3 times 2 is 6, minus 1 equals 5. That is correct, but remember it has to work for all 4. So if I use that same equation we just generated from answer choice C, and let's say I'll use the third ordered pair, so that way we're only working with whole numbers right now. Y is 6, 3 is 4, and minus 1. 3 times 4 is 12, and 12 minus 1 does not give me 6, it gives me 11. So C is out. And we are left with our answer of D, where we already knew that our rate of change was 1/2, and it's telling y is 4 more, which is true, because remember how we talked about sometimes working backwards to identify what your initial amount is. So here, if I were to make a new table with x is 2, 3, 4, 1, 0. We know when x is 2, y is 5. So if we can think about it as money, our rate of change is 1/2, which is half of a dollar. Therefore, if I go backwards, I'm taking away half of a dollar, leaving me with $4.50. And if I go backwards again, I'm taking away another 50 cents, letting me know that my initial amount is the $4. Okay, for number 4, again, you can pause the video and try this one out on your own, or if you just want to do it together, it's up to you. Now here, notice your rate of change. 3 times x, twice of x, 4 times x. And then here, for J, the value of y is 10 more than x. This, remember, is where we said we have our invisible 1 when you don't see a number that you're multiplying x by. So you can just automatically do your rate of change, which is your change in y divided by your change in x. How did I get from 5 to 9? Plus 4. How did I get from 1 to 3? Plus 2. To simplify my ratio, 4 divided by 2 is going to give me 2, which lets me know more than likely my answer will be G. But again, you can try the other ones out. F is telling you that the value is 2 more than 3 times x, which means 3 times x plus 2. G is where we have the twice, which means 2 times x plus 3 more. H, 4 times x plus 1 more. Y is just the 10 more than x. So remember how you can even convert your word problems to the equations and see if they match up with your table. And because we're saying that it's G, I'm going to check my work by also working backwards and incorporating the 0. I want to know what is the initial amount. So here it tells me when x is 1, y is 5. When x is 3, y is 9. We said our rate of change is 2. So for every 1 of x, I'm adding 2 to y. And what can I add to 2 to get 5? Well, that would be the 3, which we have right here in our initial amount. So for number 4, your answer should be G.
I have a voice, but no.
Number 5. Again, you can pause the video if you want to, or you can just follow along with me. The Luger family spends spring break camping. The campground charges a $5 entrance fee. A $5 entrance fee. Keywords there for that one-time amount. Plus $10 per night to camp in the park. Which of the following graphs best represents the relationship between the number of nights the Luger family camps and the cost? Okay, so we're going from a word problem to a graph, but what I would first recommend is setting up our equation to help us generate a table. We know that they're charging $10 per night. If you look at your graphs, all of the X values are the number of nights. So here this lets me know that I'm multiplying 10 times X. And to that, it tells me plus, so I'm adding that $5 entrance fee. Okay, now let's make our table. So for the number of nights is our X axis. The cost is our Y axis. From here, before they have stayed any nights at all, they're already charging them an entrance fee into the campground. They haven't even stayed there yet. So this is letting us know our initial amount. Now that we've identified our first ordered pair, look at your graphs. And you'll notice there's only two that have when X is 0, Y is 5. Therefore, you can eliminate G and H. Now let's continue our table. So if they stay one night, it says $10 per night. That means I'm adding $10 for one night. Now giving me a total of $15 after one night that they have stayed there. From the two options we have left, we can look for where X is 1, Y should be 15. And notice how there's only one answer choice that gives us that second ordered pair, which would be F. Okay, number 6, same thing again. You can pause the video and work it out on your own, or if you want to do it together, that is fine as well. When you're identifying the table from a graph, this one is a bit simpler because all you have to do is plot the points from your table. So let's look at answer choice A. You have -1 and then -1. So let me color code so we can see the difference. Notice how that point does not fall on our line at all. So A is out. We don't even have to continue with the rest. Now let's look at B. When X is -2, so I'm going to go to the left 2, Y is +5. I'm going up 5. I plot my point. That one did fall on our line. Now we look at the next point. When X is 0, Y is 1, our initial amount. Our Y-intercept, that did fall on our line as well. And then lastly, when X is 4, so I go to the right 4, Y is -9. Notice how this point did not fall on our line. So B cannot be our answer because it has to have all of the ordered pairs. Let's try our next one. When X is -3, Y is +7. So I'm going to the left 3 and up 7. That did fall on our line. Next ordered pair, when X is +3, we go to the right 3 and then down 5. That did fall on our line. And then lastly, when X is 5, Y is -9. That also did fall on my line. So here I can already tell that my answer is going to be C, but let me just check D to make sure. For your first ordered pair for D, when X is -1, Y is +3. Well, that did fall on the line, but remember, all of the ordered pairs need to fall on your line. So let's check the next one. When x is 2, y is -5. And that one didn't, confirming our answer should be C. Okay, for your exit ticket, same thing again. If you want to pause the video and try the question out on your own, or if you just want to follow along with me, it is up to you. Now notice for this question though, it's telling you to choose 2 answers. This is a multi-select question and it's asking you to identify the equation and table that represents the relationship between x and y in the graph. From here, let's look at our graph. And the first thing I want to identify is my y-intercept. And my y-intercept for this graph is going to be 3. So just by doing that, when you look at your equations, notice how there's only 2 equations that have the +3. From here, another reason why A and D should have been eliminated is because notice how your rate of change is going down. It's decreasing, so it'll be negative. Now we have to figure out, is our rate of change -1/2, -1/2, or -2? So to do that, we're going to use 2 ordered pairs. And remember, the ordered pair you use, make sure it crosses the x and y axis exactly. What do I mean by that? I wouldn't want to use this ordered pair right here because I don't know exactly what the x value is. You want to use where it crosses x and y exactly. So from here, when x is 0, y is 3. When x is 1, y is 1. I'm going to make my table. How did I get from 3 to 1? Subtracting 2. How did I get from 0 to 1? Adding 1. And now we do our change in y divided by our change in x. Our change in y was -2. Our change in x was +1. From here, you have to go back to your multiplying and dividing integers where you can do your tic-tac-toe, your sleepy cat, or just remember same sign positive, different sign negative. I have a negative being divided by a positive, so this tells me my quotient will be negative. From here, I can identify that it's C that gives me the -2. And then lastly, for the table, remember, just plot the points. Right away, I'm going to look for my initial amount of +3 when x is 0. So from here, you are able to eliminate E. The 0 for some reason didn't come out. Now we're only left with F, G, and H. So if you look at F, when x is 3, y is -3. So I go over 3 and down 3. That point was on my line. Then for our next one, when x is 5, over 5, down 7. That also fell on my line. You do want to check just to make sure your other 2 tables, when x is -1, y is 2, that didn't fall on our line. And then lastly, H, when x is 3, y is 0, that didn't fall on our line. So the only one that matches where all 3 ordered pairs fall on our line is F.